I'm Chris Moyer, Senior Director of Content and Research at Z-Prime. I have the great privilege of getting to sit down with Gary Rackliffe, the Vice President of Smart Grid and Grid Modernization at ABB. Gary, thank you so much for joining me today.
Well, Chris, glad to be here.
And here is at the Energy Thought Summit, ETS19, where our theme this year has been Love Your Energy. And one of the big things with Love Your Energy is how the energy industry, the utility industry, and power delivery is changing to better service customers, to better optimize the way we deliver power. And I don't think there's really a better person to talk about the change in the industry than you. You really focus on this on a daily basis. So talk to me a little bit, Gary, about what are some of the biggest trends that you're seeing impacting the industry today?
Sure. So I think there's maybe 5 main drivers that we see that are behind the changes in the industry. So we continue to see a focus by the utilities on reliability, and that's been expanded to resiliency, being able to quickly recover whenever there's a disturbance, whether it's storms or whether it's related to physical attacks or cyber attacks. But the grid needs to be both reliable as well as resilient. The second thing that we're seeing is a focus on efficiency. That hasn't gone away. That could be in-use efficiency. It could be reducing losses on distribution feeders. But also what's now coming into play is utilization. We have very low utilization factors of equipment on the grid, and we're trying to improve asset utilization and efficiency of assets. Sustainability is another big driver. Incorporating renewables and looking at electrification are components of what's driving change in the grid. Operational effectiveness, knowing the situation, situational awareness is another driver that utilities are facing. And then the last one is customer engagement. I think we're going to see a trend where demand response is going to become demand response on steroids as we try and shape load to match the non-dispatchable generation resources that are being added as part of renewable generation. And so the big things that I think right now are shaping the grid, if you look at those drivers, one is integrating renewables to the grid. The second is digitalization, applying digital technology to the utility infrastructure and utility operations, and then electrification. We talk about EVs, but it's electrification of all different types of transportation, which I think is one of the key issues that are facing the industry today.
That's such a great point, and I think we've been talking at ETS about the convergence of those trends. What comes first? Is it electrification? Is it digitalization? Is it the integration of renewables? Or does the industry have to sort of walk and chew gum at the same time and do all 3 of those things simultaneously?
So I think utilities are going to do all 3 simultaneously, and there's different drivers behind each of those. If we take digitalization or the digital grid concept, this is something that started 20 years ago. People started to take their wall maps in control rooms and put them into the computer so dispatchers had better visualization of grid operations. And so we've worked through digitization, converting analog to digital for a number of years. And now we're starting to look at digitalization, which is taking the digital information a utility has and sharing that across the enterprise so you can make better informed decisions and you can start to improve your operational effectiveness. And then the next stage of that digitalization process is going to be operational effectiveness, the business transformation to get to a better state of operations across all facets of grid operations. And so we see that sharing of data. We also see the industrial Internet of Things, software, connectivity, which is communications, and then the control of devices out in the field as another component. Renewables are being driven by reduction in cost and greater focus on greenhouse gas emission reductions. So as costs come down, it enables more investment to take place with renewables. So we're seeing wind and solar in particular now reaching parity with some of the thermal generation options. There's a challenge though, they are variable resources. They're not dispatchable. If the wind isn't blowing and the sun isn't shining, as everybody says, you don't get power. So that's an operational challenge. How do you coordinate those resources with your other central generation resources? What's the role of storage and how can that facilitate additional renewable investment? Can we do things with shaping load? You know, if you have excess solar in the afternoon, rather than curtail it, can you move load to match that excess generation and make the grid more efficient as a result? And I think those are the things that are going to continue to drive us and to expand the development of more renewables. And then electrification of transportation, that's the other component of trying to reduce greenhouse gas emissions. But the big hurdle has been, or two hurdles, one has been range and the other has been cost. So as range of vehicles increase, you know, we're now talking about 300 miles of range with an electric vehicle, and the amount of time to charge that is decreasing with some of the fast DC charging, and we're almost to the point where first cost is on par with an internal combustion engine. Total cost of ownership has reached parity, but first cost is still a little bit higher. But all those dynamics are now removing some of the hurdles to get wider application of electric vehicles. I think we'll see fleets, electrification of fleets be adopted first, because you have controlled routes, controlled distances, and you can put the charging infrastructure where you need it to manage fleets. Also, fleets are run by businesses, so there's less emotion. It's more bottom line, and if it makes sense from total operating costs, people are going to move forward to electric vehicles or electric delivery trucks or whatever the case may be. We're also seeing electrification of buses. Trucks might take a little bit longer, particularly long-haul trucks. You have an issue of how much weight the batteries are versus how much you can carry when you start to go to long-distance trucks. But certainly buses, certainly fleets. We're actually electrifying boats. There's some ferry boats in Scandinavia that are now being electrified. So we're expanding the concept of electrification beyond just individual private vehicles. And the big challenge will be, can we charge these vehicles without increasing peak demand on the grid, which then in turn requires more capacity?
And it seems to me that digitalization, and that enterprise integration really are the key fundamental building blocks that allows simultaneously for that electrification and that increase in renewable energies on the grid. It's because you have this data about what's going on and are able to communicate it at real time. That's going to be what will allow these other two major trends to occur.
I think the digitalization, or the concept of the digital grid, allows broader coordination across different resources, loads, controlling loads. You know, the point being, can we use renewable generation when it's available, for example, to charge electric vehicles and coordinate that? You can't do that unless you have advanced your level of digitalization of the grid.
Gary, thank you so much for sitting down and talking with us at ETS19. We really appreciate your perspective on all of the great trends that are happening in the utility industry.
Well, thanks. I think we have some exciting times.